I am Dr. Pushpal Ghosh, working as an assistant professor in the Department of Chemistry of Dr. Pushpal Ghosh Central University Sagar, is delivering the lecture on the topic, important topic, an Odyssey of Indian science from ancient to Renaissance. Today, I will discuss about the third part of the lecture, that is resurrection of Indian science and Renaissance. So, in my last two talks, we have seen how Bharat or India marked her glorious footsteps in different facets of knowledge, especially in science since time immemorial. India has given the world zero, Sanskrit, yoga, Ayurveda and two of the world's first universities at Nalanda and Taxila. But then from the 11th century, India entered in a dark age with destruction of great learning centers by invaders. By the time British colonized India, it has lost much of its knowledge chain and once cherished scientific vigor. On 23rd June 1757, East India Company seizes power in Bengal, and their interest from trade changes to occupying territory. Slowly, Mother India came under the grip of British colonizers. Her wealth are looted, plundered systematically. Her indigenous education system is discarded by new rulers. India and her children entered a darker age. Then from the 19th century, a new age of enlightenment began, and Calcutta was the epicenter of Bengal Renaissance. Raja Ram Mohan Roy, pioneer of the Indian Renaissance, wrote to British government in December 1823 that India needs a science institution. In 1817, a group of enlightened Indians and Englishmen set up the Hindu College, which was later named as famous Presidency College. University of Calcutta was founded on 24th January 1857. In 1906, Ashutosh Mukherjee fulfilled Roy's dream of Science College. In 1914, with generous donation from Taraknath Palit and Sir Rasbihari Ghosh, he launched the University College of Science and Technology. Meanwhile, at Presidency College, two young MSc students were making waves. S.N. Bose and Meghnad Saha stood jointly first in their MSc examination and were ready to take on the world. Meanwhile, a very different revolution was taking place in Europe. Many aspects of conventional physics of Newton and Maxwell got questioned. In a remarkable effect, Mahendralal Sarkar, second MD from Calcutta Medical College, established Indian Association for the Cultivation of Science, ISS Kolkata, at 1876. ISS was the first National Science Association of India. At ISS, another young scientist, C.V. Raman, was creating a stir with the experiments and paper. Similarly, Pandit Madan Mohan Malviya established Benares Hindu University in 1916. Shantiniketan or Vishwabharati was established by Gurudev Rabindranath Tagore. Similarly, Sir Dr. Hari Singh Gaur established our university in 1946 by donating his hard-earned personal money. One of the pioneers of modern Indian science, especially chemical science, is Acharya Prafulla Chandra Ray. He was born on 2nd August 1861, Khulna, presently in Bangladesh. He studied at Hare School and then at Albert School. In the year 1882, he received prestigious Gilchrist Scholarship and studied in University of Edinburgh. He received his DSc in the year 1888 and returned to India in the year 1889 and joined as an assistant professor, Presidency College. He was a brilliant teacher and scientist, but he started to explore Indian science, especially how chemical science of Bharat grows since time immemorial. In 1902, first volume of Hindu chemistry was published. To me, this book is no less than Swami Vivekananda's speech at Chicago at 1893. This book removes the misconception about scientific temper of Indians in the West. Second volume of this book was published on 1908. Acharya Prafulla Chandra Ray retired from Presidency College and joined in Calcutta University as head of the department and Palit professor. In 1924, he took lead to establish Indian Chemical Society. Acharya was a visionary. He understood that science should be linked with entrepreneurship and established Bengal Chemicals. He donated almost 90% of his income every month. He belonged to nationalistic school and the emancipation of India, political, social and economic was his life stream. Acharya Prafulla Chandra Ray passed away on June 16, 1944. Sir Edward Thorpe wrote in Nature in 1919, her India's elevation will not come in Sir Prafulla Chandra Ray's time. A small spare man in feeble health and a confirmed dyspeptic, he will be spent in her service, but the memory of this service will be always remembered. Sir Jagadish Chandra Bose was another brilliant Indian scientist who has spent his life for the cause of science. He has expertise as a biologist, physicist, botanist and an early writer of science fiction. He started at Hare School at 1869 and then St. Xavier's School, St. Xavier's College. He passed BA in 1879 and again BA in Natural Sciences in Tripos. He got Tripos from the University of Cambridge and a BSc from the University College of London in 1884 and a DSc from the University of College London in 1896. Amongst Bose's teachers at Cambridge were Lord Raleigh, Michael Foster, James Dewar, Francis Darwin. At the time when Bose was a student at Cambridge, Prafulla Chandra Ray was a student at Edinburgh. In this regard, I want to share an example how patriot Sir Jagadish Chandra Bose was. He joined at Presidency College, Kolkata after returning from England, but he was denied salary as per other white professors in the same institute. He protested and denied to take salary almost for a long time, but he continued high-end research. In Presidency College, he discovered wireless communication. Though he was not given Nobel Prize, but a crater in the moon is dedicated by his name. He was not only the father of radio science, microwave optics, but was a truly multidisciplinary researcher. He also made significant contributions to plant science, invented the crescograph, a device for measuring the growth of plants. Also, he laid the foundations of experimental science in the Indian subcontinent. IEEE named him one of the fathers of radio science. He also founded Bose Institute in 1917. The institute was the first interdisciplinary research center in Asia. Let us discuss about Bose, Raman and Saha, which is called the quantum Indians. Let us start with Satyendranath Bose, another Bose. Along with Sir Jagadish Chandra Bose, another Bose was making waves in science at that time. He is no other than Satyendranath Bose. From his childhood days, he was very patriot and compassionate in nature. In case of famine and other calamities, many times he would go out and dish food away from the table and feed the poor outside. His childhood was immersed in art, culture, music and education, but he demonstrated his command on mathematics from very early. Bose stood first in BSc and then he and Meghnad Saha took joint first in their MSc examination. They got 2 years from Sir Ashutosh Mukherjee to start the physics department. Most of the important papers were published in those time in German and French. So, they learned French and German. They were the first people to translate the Einstein papers on relativity into English, and that was published in Calcutta University. Obviously, they were making waves. Bose moved to East Bengal in 1921 and became reader at the newly founded physics department at Dhaka University. 4th July 2012, scientists at CERN announced with 99.997 accuracy the discovery of the Higgs boson particles, that is so-called God particle. CERN were catching a snap of the first few moments after the Big Bang. People in India awake to the realization that there was a Bosch in boson. In 1924, a young and completely unknown Indian scientist sent Albert Einstein a letter, and resulting publication would change physics and Indian science forever. Earlier, Planck came up with the very basic idea of quantum. Planck somehow wrote the formula which fits all the experiments data. Max Planck came to the conclusion that energy is being let out by the discrete energy quantities of particles. He called these particles as quanta. The equation comes to be known as Planck's law. This was just beginning of the quantum age. Then three amazing developments occurred. Einstein demonstrated that light was both a wave and made up of particles. He called them light quanta. Lord Rutherford discovered the solar system model of atom with dense positive nucleons and electrons spinning around it. And finally, Niels Bohr demonstrated that those electrons could only move at quantum energy levels predicted by Planck. And then fourth and final shot were made by Bosch in 1924. While teaching a class on quantum physics, Bosch had a eureka moment. Bosch was disappointed with the way Planck's law was being derived in Europe. Earlier, Ludwig Boltzmann had developed a mathematics using probability of Einstein photons using Planck's equation. In the same way, a new statistics would be needed that could work at the quantum level to count photons. This was Bosch's great breakthrough. What he had shown was that in the case of photons, classical statistics does not hold. It is a new statistics which is now of course called Bosch statistics. So, there are new kinds of objects which people were not aware of. So, the first paper was called Planck's law and the light quantum hypothesis. He sent his paper first to Phil Mag in Britain, but it was turned down, and then in one of those seminal moments in history of physics or science, he decided to send this paper to Albert Einstein. It was a bold discussion and became one of the great moments in modern science. He wrote, "Respected sir, I have ventured to send you the accompanying article for your perusal and opinion. I am curious to know what you think of it." So, Einstein was delighted. He said, "This is what I was looking for. My photons are not like classical billiard balls, they are bosons." So, overnight, Bosch became a very famous name in the world of physics. Einstein then sent a postcard to Bosch saying this work was a beautiful step forward. When Einstein postcard arrived, Bosch became an overnight celebrity and was immediately granted permission to travel to Europe to meet Albert Einstein. First year he actually spent time with Maurice de Broglie, who was setting up the X-ray crystallography lab. Then he worked for 6 months with Madame Curie. He proceeded to Berlin in 1925 to meet Einstein. Einstein said, Bosch's way of counting should not only apply to photons, it should also apply to material atoms. That was Einstein's extension of Bosch's idea. You get, for example, you get quantum gas of material particles, and finally, that at very low temperature, everything can condense. If all the particle condense into the lowest energy state, then you have a new state of matter, which was now come to be called Bose-Einstein condensate. Now, in 1928, Paul Dirac wrote a very famous book called Principles of Quantum Mechanics. In that book, he coins the two words bosons and fermions. So, we can say that half of the particles in this universe are bosons, and as somebody said, as long as there is light in this universe, there will be bosons everywhere. So, one simple idea in Dhaka completely revolutionizes everything. Those 6-7 Nobel Prizes were awarded so far related to Bose-Einstein condensation. Bose was not given Nobel Prize. When this was asked by journalist to Wolfgang Ketterle, who won Nobel Prize for Physics in the year 2001, during his visit to Kolkata, he replied that if someone's name is associated with the half of the universe particle, does he need any prize? Bose returned to Calcutta University in 1945. He founded the new organic chemistry labs and also worked on trying to solve the unifying theory of physics that Einstein had been working on. So, Einstein used to call it the unitary field theory. He found it very odd that there were both waves and particles, and he proposed a theory which would do this, and there are various objections, and Einstein started communicating with him again. Bose wrote the paper and very eager to discover, but Einstein was passed away before the meeting takes place. And the story is that when this new news arrived, he simply threw that paper into a basket. So, there is the unfinished symphony hanging these. Rabindranath Tagore dedicated his seminal work on science to Bose after hearing about him from Einstein. In 1956, Bose became Vice Chancellor of Shantiniketan. The vision was to bring about a scientific revolution in Bengal, but Bose faced obstacles from the states also at every turn. Bose was finally inducted as a fellow of the Royal Society. In 1959, he became first national professor of physics and started teaching at ICS Kolkata, which Raman once had made famous. He thought ICS is the best place for research. Bose did not get the Nobel Prize, but how many Nobel Prize winners' name is learned by every physics student? Bosons and Bose statistics is so fundamental in modern physics that Bose statistics we would not have been able to count photons and predict their behavior without Bose statistics. Laser, fiber optics, communications, superconductors, or the future in quantum computing is also required Bose statistics. Without bosons, we cannot understand how matter come into being after the first few moments of the Big Bang, or what makes up the most of the universe at the quantum level. He makes science available to Bengalis in the mother tongue. This was his life mission. He said in his book, "When I talk about learning science through the mother tongue, I am not thinking of people like you, that means scientists, who will be actually doing science. It is for the general people." Bose spent rest of his life teaching at ICS and at his home, playing the flute and discussing philosophy and teaching young minds about the new formation of science. 4th February 1974, S.N. Bose passed away. We can say that, well, after all, if one has lived through so many years of struggle, at the end he finds that his work has been appreciated, then he does not need to live long. It is Bose's famous quote. Now, I will discuss about Sir C.V. Raman, one of the finest scientists Mother India ever produced. He is the C.V. Raman, as I told, only Nobel Prize winner in science from India. Raman, the man who scattered, believed that the human spirit never ceases from questioning or questioning. Why was the sea blue? Why do flowers have colors? How the tabla does makes a sound? Why did crystals reflect so many spectrums? He was a man of many contradictions, a great teacher, but an intolerant perfectionist, a simple man, but supreme egotist, but without doubt a genius. C.V. Raman was born in November 1888 in a conservative Tamil family. His father was lecturer at Presidency College, Madras, and completed MA at the age of 18 from Presidency College. As a young man, he was deeply influenced by Edwin Arnold's famous book, The Light of Asia, as it explored the light of the Buddha who overcame the problems of his age through intellect and willpower. He stood first in the Indian Financial Service exam and got a job as the Assistant Auditor General, Government of India, and came to Calcutta. One day, when he was returning from his office, he saw the notice board of Indian Association for the Cultivation of Science. He went there, found a good library and some instruments. He started working there at the evening. He published his first paper on the effects of vibrating strings in the year 1909 from ISCS. Then he moved to Calcutta University as Palit professor. On a trip to 1924 in Europe, he was amazed by the rich blue color of the Mediterranean Sea. This resulted in a paper he wrote on board of the ship on the molecular scattering of light in water and color of the sea. This was the bearing of his love affair with light scattering that would eventually lead to his Nobel winning discovery. When light scatters, the color of light changes, and actually this change in the color is what we call the Raman effect. Raman, his student Ramanathan and V.S. Krishnan separately reported the same phenomenon. For example, if we pass a green light through a liquid, we may get a very weak yellow, though with a very small fraction. So, though the light which is coming has just one wavelength, but when it is scattered, it generates many different lights with different wavelengths. The scattered light is a fingerprint of materials. The fingerprint is so unique that we can use it in the material science by using the Raman effect. When Raman and his student observed and convinced about some new property of scattering, Raman approached to G.D. Birla, one of the great industrialists and philanthropists of his time, for monetary help, because that time British cannot give the money for research, so that he can buy a spectrograph. G.D. Birla actually gave this amount of money, and Raman and the student observed this phenomenon. So, the first paper he sent to Nature in telegram and wrote everything in a nice form, and he published it from the Indian Journal of Physics. Then he sent the paper by post to several Nobel laureates, Rutherford, Niels Bohr and others, to nominate him. He called a press conference on 28 February in 1928. It came out next day, and that is the reason it is called as National Science Day. Now, the question is, why this discovery creates the attention? Does matter also behave as a quantum object, or we can continue to describe matter as we had described it from Newton's time? And that is the importance of Raman's discovery. After this great discovery, Nobel laureates proposed Raman for Nobel Prize. Nobel Prize winning telegram came to him on the 15th of November 1930. Incidentally, Raman dedicated his Nobel Prize to the freedom fighters of India, who are spending their golden time at British jail. In a speech to the Royal Society, Lord Rutherford said, Raman effect must rank among the best 3 or 4 discoveries in experimental physics. In 1929, he became known as Sir C.V. Raman after being bestowed with a knighthood. In 1934, he became director of ISC. He wanted to give job to many European scientists during the World War II, but board denies, and then Raman was forced to resign. He spent rest of the years with teaching and researching. He also established Indian Academy of Science and then Raman Research Institute. 2 components of Raman's legacy, that means Raman effect itself, which was discovered in 1928, continues to be at the forefront of the scene and technology today in a manner that was never anticipated. Its applications in chemistry and biology are really great. For example, intercontinental communication, optical fibers are one of the very important applications of Raman effect. Light is carried by the signals, we all know. The Raman effect is being used to transmit signals which are coded into light. This is something that if Raman had been alive today, he would have been absolutely thrilled. It can be said that he also told this, a purposeful life needs an axis or hinge to which it is firmly fixed and yet around which it can freely revolve. As I see, this axis or hinge has been, in my own case, strongly enough not the love of science, not even the love of nature, but a certain abstract idealism or belief in the value of the human spirit and the value of human endeavor and achievement. 21st November 1970, he passed away. Incidentally, Raman's memorial was a tree. Now, I will discuss about another very important scientist, Meghnad Saha. Meghnad Saha, the man who fingerprinted the stars. He recolonized modern astrophysics. His equation helps to measure stars' temperature and composition. Professor Saha had realized the immense potential that nuclear science had for the country's development and brought nuclear physics to India. He brought nuclear physics to India when the world was just discovering it. He launched Institute of Nuclear Physics, which is currently known as Saha Institute of Nuclear Physics. Meghnad Saha, he was basically a fighter. Right from the childhood, he fought against poverty. He fought against the apathy of the society. India of his dreams was to build on a foundation of basic science and would lead the world once again in intellectual excellence. Born in Eastern Bengal in 1893, he loved maths and history. He excelled on almost all subjects. He loved stories about Marathas and Rajput kings and saw himself as a new kind of warriors for India's future. He was also involved in freedom movement and come in touch with Subhash Chandra Bose and Rajendra Prasad. Meghnad Saha and Eshen Bose joined Calcutta University in the year 1916, as I already told. He wrote a series of papers on quantum mechanics and thermodynamics during the time in the 1917 to 1919. In 1919, Saha won Prem Chandra Rai scholarship to go to Europe or study leave for 2 years. He headed for Alfred Fowler's famous laboratory in London. In the following years, he went to work in the Berlin with Walter Werner's. In the year 1919, he had begun to develop the theory that would make him famous. Astronomers were always curious to know what sun is made of. Eddington, those time predicted sun is made of metals, but actually sun is made of hydrogen. But how people come to conclusion? Saha told that if you excite an atom, they go to excited level, and when they come back, they emit a radiation. So, he gave the equation which took into according the temperature and pressure. From this, that a star's temperature can be calculated by the measurement of its line of emission. He was the first person to apply quantum theory to stellar objects. Though Saha's equation was an extension of the quantum physics, but it led to a tremendously profound application in astrophysics. He wrote a paper entitled that ionization in the solar chromophase, and it was published in Field Mag in 1920. A young lady in Harvard, Henrietta Leavitt, used Saha's equation to calculate the amount of hydrogen in sun. Her thesis examiner, Henry Norris Russell, professor of astrophysics at Princeton University, recalculated and confirmed that sun and stars are made of hydrogen. In 1921, he returned to Calcutta as Khoira professorship in the years 1921. After few years later, he moved to Allahabad University, and where he built a new physics department. In the year 1927, he was elected as a fellow of Royal Society and nominated for Nobel Prize in the year 1930. Again, he returned to Calcutta as a Palit professor and as head of the department in the year 1939. Netaji Subhash Chandra Bose proposed India should have a planning commission, and with Jawaharlal Nehru as the chairman and Meghnad Saha as member. He planned many things like atomic energy to be introduced. He started to teach nuclear physics in 1940, and he became secretary of ICS in the year 1944, and president of ICS in the year 1946 and tried to rebuild ICS. In 1947, he launched the Institute of Nuclear Physics at Calcutta University, which is honored as very prestigious institute nowadays, Saha Institute of Nuclear Physics. Incidentally, he joined in politics too. In 1952, he became an independent member of Indian Parliament. Ironically, he died on a massive heart attack on the stairs of the Planning Commission. On his passing, D.S. Nothan said, "The life of Saha was in a sense an integral part of growth of scientific research and program in India, and the effect of his vicious and personality and would be felt for long time to come in almost every aspect of Indian science activity. His dedication to science will long remain as inspiration and an example. What they give us, Bose gave us Bose science and statistics and condensate, and all bosons were named after them. Raman gave us Raman effect and India's first and only Nobel Prize for science. Saha not only revolutionized astrophysics, but also built a substantial part of India's science infrastructure in its early days after independence. India seems to have lost its love affair with basic science and research." I have tried to show how science and scientific temper blossomed in this ancient land since time immemorial and achieved its highest peak, then how and why it declines in the medieval period, finally how it bounces back again from the ashes since 19th century to our glorious independence. So, it is important for us to know what to do in this regard. Creation of new knowledge for betterment of society and civilization is one of the rational duties of any individual. As a young nation, but part of the oldest civilization, oldest living civilization, it is our duty to create an inclusive society without any bias and prejudice, so that every children of Mother India can pursue in the highest level of knowledge questioning. Our society should be strong internally, so that we can repel any attack and can protect and improve our nation, her civilization and knowledge chain. Thank you very much.